In this video, we're going to be taking a look at a limit example involving a radical. The limit we're going to be looking at is the limit as x tends to infinity of the square root of x squared plus 5x plus 1 minus x. Now, some people use the term square root and radical interchangeably, but if your math teacher is really anal, they'll say that radical is a more general term. It could also include cube roots, fourth roots, fifth roots. Square root's a specific case of a radical. But I just went ahead and used the more general term here because more pedantic math teachers tend to like to use radical instead of root. And a square root's just a type of radical. Okay, when you plug in a really big number for x here under the square root, for the terms under the square root, you get a really big number squared plus 5 times a really big number, and you add 1 to it, you get a massive number. You take a square root, you get a smaller but still massive number, and then you subtract that number itself. And you might be tempted to say, this is infinity minus infinity equals 0, but this is not correct because you don't really know that these numbers are equal, and they're usually not equal. So you can't really say that this is it the question, is it equal to 0? We don't know. So this is one of our indeterminate forms, and hopefully you recognize that from the indeterminate forms video. So this just means we have more algebra to do to find out what this limit is, if it exists, or perhaps it doesn't exist. But either way, we have more algebra to do. And from your algebra courses, you probably remember that whenever you saw a radical plus or minus something, that you were instructed to multiply by what's called its conjugate. So here we have the square root of 5x squared plus 5x plus 1 minus x. The conjugate of that is the square root of x squared plus 5x plus 1 plus x. So that's just what's under the square root. If you have x subtracted from it, then the conjugate is what's under the square root with x added to it. Now if this were your original expression, square root of x squared plus 5x plus 1 plus x, then square root of x squared plus 5x plus 1 minus x would be the conjugate. And you'll see why we do that here. So we multiply and divide by the conjugate because we can't, in order for these two terms to be equivalent, we can only multiply by 1. So if we want to multiply this by 1, we can multiply by the conjugate over itself. And so that's exactly what we're doing here. And what this does is this gets the square root or radical out of the numerator, because this times itself is basically this would be the square root of x squared plus 5x plus 1 squared, then minus x times the Well, perhaps you're used to doing FOIL. So first outer, so plus x square root of x squared plus 5x plus 1 minus x square root of x squared plus 5x plus 1 minus x squared. So that's our numerator. And in the denominator we have the, oops, this should be extended, square root of x squared plus 5x plus 1 plus x. Okay, so the square root of something squared is just itself. So this first term is just x squared plus 5x plus 1. You can see that this is plus the square plus x times the square root of x squared plus 5x plus 1. This term is minus x times the square root of x squared plus 5x plus 1. So these cancel. And we can just write down this minus x squared term. That's our numerator. In the denominator we still have square root of x squared plus 5x plus 1 plus x. So these x squareds cancel. We're left with limit as x tends to infinity of 5x plus 1 over x squared plus 5x, square root of x squared plus 5x plus 1 plus x. Now here when we plug in a really big number for x, multiply it by 5, add 1, we get another really big number. In the denominator, plug in a really big number, square it, add 5 times itself, and then add 1. We get a huge number. Take the square root, we get a much smaller number, but still a very huge number. And then add itself, we get another huge number. So we end up with another indeterminate form. So we started with one indeterminate form, and looks like we got another indeterminate form. So what do we do here? Well, in a previous video, we divided both numerator and denominator by the highest power of x present, and that's x here. And here you have x. Here it looks like you have x squared, but you actually have the square root of x squared, which is x. And this point's important to note here. The square root of x squared, in general, it's the absolute value of x, and all that's saying is that you know, for the square roots by definition are always positive. So let's say x were -7 and you had -7 squared. Well, the square root is 7. So here in this case the square root of x is not x, it's -x. Okay, but if x were 7, the square root of 7 squared is 7, so it's x itself. But in either case, whether x is positive or negative, the square root of x squared is the absolute value of x. It is, you take you take whatever x is and you make it positive. So if x is negative, the absolute value of x would be negative x. So here, make this clear. Say x equals -7. Then square root of -7 squared equals 7 equals negative x. Then say x equals 7. Then the square root of 7 squared is 7 because square roots are always positive, but that's equal to positive x here. So why did I bother mentioning that? In general, the square root of x squared is the absolute value of x. We're concerned with the limit as x tends to really big positive numbers. So if we know x is positive, then so if x is greater than or equal to 0, then we know that the absolute value of x equals x. So we can just write the square root of x, and the square root of x is equal to x. And that's the case we have here. So why did I bother with all of that? Well, I'm going to rewrite this limit here. Have the limit as x tends to infinity of 5x plus 1 over the square root of x squared plus 5x plus 1 plus x. So I'm going to multiply and divide by the highest power of x, which is x squared, which is x, not x squared. This here you have square root of x squared, but remember that's x. So the highest power of x present is x. I'm going to multiply both numerator, I'm going to divide both numerator and denominator by x. Because doing the same thing to both numerator and denominator, dividing both by x is the same thing as multiplying by 1, because I'm multiplying both numerator and denominator by 1 over x, or dividing by x, same thing. So numerator we have 5x plus 1 divided by x. The numerator, in the denominator, I'm just going to write the division by x as multiplication by 1 over x. We have 1 over x times 5 times x squared plus 5x plus 1, should put a parentheses here, plus x. And in the numerator, it's the limit as x tends to infinity of 5. First term, 5x over x is 5, plus 1 over x. And in the denominator, it's 1 over x. Remember, because x is positive, this in general 1 over x would be these. It would the absolute value of 1 over x would be equal to the square root of 1 over x squared. But because x is positive, 1 over x itself is equal to the square root of 1 over x squared. So in this term, multiplying by 1 over x would be the same thing as multiplying by the square root of 1 over x squared. So this is square root of 1 over x squared times square root of x squared plus 5x plus 1, and plus x times 1 over x. So we have the limit as x tends to infinity of 5 plus 1 over x divided by all this stuff, and now we're just going to simplify this. The square root of 1 over x squared times the square root of x squared. Well, we can write this as the square root of x squared plus 5x plus 1 divided by x squared. So the square root of x squared plus 5x plus 1 divided by x squared. And x times 1 over x is just 1. So this is the limit as x tends to infinity. 5 plus 1 over x divided by x squared over x, the square root of x squared over x squared is 1. 5x over x squared is 5 over x. Go ahead and erase that, make this a little bit clearer. Five over x. And to be clear, all this is under the square root. Plus 1 over x squared. This is also under the square root. And outside of the square root, we have plus 1. So now we take the limit as x gets really big. Oops, there should be a 1 over x. As x gets really big, 1 over x approaches 0. 5 plus 0 is 5. Numerator, we have 5. And now looking at this piece under the square root, as x gets really big, 5 over x gets really close to 0. 1 over x squared gets really close to 0 because x squared gets increasingly large, so 1 over x squared is going to get really close to 0. So this whole term would be the square root of 1 plus 0 plus 0, or everything under the square root. Square root of 1 plus 0 plus 0. And outside of the square root, we have plus 1. Now we have 5 in the numerator, and really the square root of 1 plus 1 is just 5 over 2. So in this problem, we started out with an indeterminate form, which was infinity minus infinity. And you can't in general say that that's 0, and we found out in this case it's actually not. It was 5 halves. We rationalized we multiplied and divided by the conjugate of our original expression here. But that got us to yet another indeterminate form. So then we went ahead and multiplied and divided the numerator and denominator, we divided both the numerator and denominator by the highest power of x, which is x in this case. This x squared is the square root of x squared, which happens to be x. We can drop the absolute value because we know x is positive. So we divided both numerator and denominator by x. And that helped us get this limit to a form where some terms dropped out, and we ended up with a singular number limit, 5 over 2.